Lesson 3.1, what is a function? A function is just a relation where each input, x, has exactly one output, y. So your x values are not going to repeat. X's don't repeat. Now, you're not going to see this much, but you might hear of domain and range. Domain are just your x values in a function or even a relation. Range are the y values in a function. Now, the vertical line test is something that we're going to use on graphs to determine if it's a function. If a vertical line only crosses one point at a time on a graph, then it's a function. That's because when we draw a vertical line through a graph, the x-coordinate should not repeat, so it should only occur one time, so it'll only have one point that it crosses. Now in our example, we're going to see several different types of relationships, and we want to decide if it's a function. We could see these as a table of values, a set of ordered pairs, a graph, an equation, or we could see it as something called a mapping that I'm going to show you in just a little bit. A part, we have a table of values and we want to know if it's a function. So our definition of a function says that each input, x, has exactly one output, y. We also have the hint that our x's don't repeat. So I'm going to look at the x's. I have -2, -1, 0, and 1. They're all different. The x's don't repeat, so yes, this is a function. Just as a little explanation, the x's don't repeat. Part B, we have a set of ordered pairs. Do you notice this little symbol on the outside of them? That's just saying that it's a relation. It's a set of ordered pairs. Now, we're just looking to see if all our x's are different. We have 0, 3, -1, and then 3. Notice that these 3's repeat. So the x's repeat. So no, this is not a function. C part, we have a graph, and we want to know if each input, each x, has exactly one y. We could do this by using the vertical line test. So I'm going to use the vertical line test. So I could test out several different places with the vertical line. I could try right here. It crosses one time. Or I could try here. A vertical line crosses one place. I could try here. A vertical line crosses one place. No matter where I draw my vertical line, it crosses one time only. So yes, this is a function. D part is a mapping. We don't use these much, but you could see it, and you'll see it when you get into Algebra 1. This just shows what my x values on the left go to for the y values on the right. Now I could look at them as ordered pairs. This would be 5, 10, 10, 30, 15, 40, and notice that 20 goes to two different y values, 20, 20 and 20, 50. So notice that the 20s for x repeat. You'd notice 20 maps to two different values for y. So my input x has two outputs y. So no, this is not a function. Part E, we're given an equation, y equal 5x minus 1. Sometimes the equations are a little difficult to determine because we don't visualize them, so we're going to visualize this by making it into a graph. We know how to graph this equation. It's in slope-intercept form. So I've drawn a coordinate plane, and I notice that M is 5, which is 5 over 1, and B is -1. So I start on my y-axis where B is -1, And then I use my slope, rise over run. I rise 5, run 1 to plot a point. I could also go down 5, left 1, and plot a point, which would be just slightly off of what I've placed there, and then draw a line through them. Now I want to use that vertical line test. So we're going to go to the vertical line test. And if I draw a vertical line anywhere, it crosses one point. I could do another one. I could draw a vertical line here. It crosses one point. Actually, if I drew a vertical line here, I don't see it cross a point, but it eventually would. But it doesn't have to cross a point. It just doesn't need to go, it doesn't need to cross more than one point. So that would also be okay. So using the vertical line test, yes, this is a function. Okay, our last problem, we're given an equation again, y equal x squared plus 1. Now we're not familiar with how to graph this equation, but we do know that we can take any equation and create a table of values to see what it might look like on a graph. So I'm going to create a table of values. I'm going to choose some x values and plug them into the equation to get the y values. So I'll choose -2, -1, 0, 1, and 2. And I'll just plug them in. Y is equal to x squared plus 1. So that would be -2 squared plus 1, which will be 5. We can go to a calculator. And so we get 5. -1 squared is 1, plus 1 is 2. 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. So we've got a set of ordered pairs, or a table of values that we can pull our ordered pairs from, and we'll graph this. So we get the points -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. Notice that it doesn't appear to make a straight line. It actually, if you follow the points, makes a curve, kind of makes a U shape. And you're going to see this U shape anytime you have an equation that includes an x squared. It's called a quadratic equation. And you don't really have to know that right now, but that's just a bonus. You hear that it's called a quadratic equation. And I'm going to test my vertical line test. That vertical line goes through one point. I can test it some other places. Over here on the left, it's not perfectly vertical, but it only goes through one point. No matter where I choose, it's going to go through 1 point or 0 points. And then eventually, it'll keep going through 1 point. So it passes the vertical line test, so yes, this is a function.